Alright, so first thing you're going to want to do is pull up LabVIEW. Okay, I'll go ahead and pull up LabVIEW 2014. Or whatever version you have is fine. Okay, I think the versions in the lab computers are 2015. Okay, so it should be okay. Alright, next thing you want to do, make sure your robot's turned on, which mine is, plugged in, everything's good to go. Go ahead and say File and New NXT EV3. Okay, this won't show up if you just have the base version of LabVIEW. You have to have the EV3 plugin for that. Just choose the robotic project. Next up, you want to choose a blank robot and hit Create. So I'm going to call this Lab 2, I don't know, V3. I think I have a couple of versions already in that folder. Bless you. Alright, so this pops up. First thing you want to do is make sure that you choose the correct NXT or EV3 target. Mine just happens to be named EV3. Whatever yours is named, it should show up here. Okay. Let me go ahead and disconnect, reconnect. Unplugged it when I come here for class. Should automatically recognize it. One of the things it may say is that you need to update your EV3 firmware. Sometimes it says that. Just if it says update the firmware, just go ahead and update, excuse me, the firmware only, okay? Plug it back. Alright, so now we got EV3. Next thing you want to do is open up the schematic editor. So depending on what kind of robot you built, this is going to change. I have just the base robot built here. So for my particular robot, I've got a large motor on port B and port C. I have another large motor. So let's go ahead and do that. Now again, if you're using the NXT kits, you will simply choose the NXT motor, and your brick will look like a NXT, the older style brick. Okay, it should be a very similar process. One thing you actually can do in this, which works out to your favor, is you actually can name these, like I can say left underscore motor. Another thing you can do from this window is check and see if the motor actually works. You can run the motor. I'm not going to do it now for the sake of time. You can run it forward, backwards to see if everything works. The encoders is working, so just to make sure all your sensors work. Now in my case, in sensor port 1, I have a touch sensor, and in sensor port 4, I've got a ultrasonic sensor. Okay, and again, it depends on what kind of robots you have and you've built. Okay, everybody's going to be slightly different compared to that. Okay, all right. So after that, again, I'm just going to leave my name the default. I might name this one right motor just to make it consistent here. And again, it's going to be on port C. I'm going to go ahead and save that schematic. I'll go ahead and close out of the schematic entry window. And then I'm going to say a new VI, okay, and a new NXT or EV3 target. So I'll call this the same name, so Lab, let's see, 2 V3. Alright, it's going to come up with your two windows. So again, if you've never programmed in LabVIEW before, this is going to be fairly new. The left window is called the front panel, and that's like your graphical user interface. You're not going to do a lot with that in this class until later on in the semester. The right panel, which is the block diagram, is what we're worried about. Okay, this is where all the programming takes place. So I'm going to minimize this for a moment and then make this full screen. So if you look here at the bottom left-hand corner, it says EV3 USB. Okay, that's why you know you're connected to your EV3 or NXT kit, and you have the correct instance installed. Okay, so again, kind of get you a little bit familiar. I'm not going to go over this in detail because there's literally hundreds of YouTube videos out there on basics of LabVIEW and basics of this stuff. Okay, so we're going to go through this pretty quickly. So at the very top, you've got the run button, the deploy button, which should be very similar to the buttons down here in the corner. Let's get rid of all this. So the same thing as the deploy here is the exact same thing as the deploy in the LabVIEW software. Okay, this stuff up here you're not going to worry about so far. How you add different blocks to the main interface is you right click with your mouse, and you're going to see what's called the functions palette. Okay, so on the front panel, it's actually called the controls palette. So see, this says controls. So again, there's two different palettes. There's the function palettes and the controls palette. Okay, so one thing I will note for the video is that since you're using the EV3 instance of LabVIEW, it gives you a reduced instruction set. So normally LabVIEW has a ton other different modules here. This only has the module for Mindstorm robotics. It kind of reduces the number of pallets it shows you just for these little robots, okay? So if we look here, we have a programming block, which is kind of similar to the, I think, the orange tab in the other software. Again, if you're not super familiar with LabVIEW, but familiar with other programming languages, this should be pretty familiar. You've got your basic structure, so you've got a for loop, while loop, case structure, which is going to be analogous to the, let's see, what was it called? It's called the loop inside of the other program is the same thing as a while loop. Also, the switch inside of the EV3 software is the exact same as a case structure or a stack sequence inside of LabVIEW. Again, there's a lot more tutorials of this online. I would suggest going to the labni.com site to kind of look at some of their video tutorials on this, okay? So let's make a simple program. So we know we have to start off with a loop, okay, while loop in this case. You're going to draw it out. So I left click and drag it out to make a new while loop. The first thing you're going to notice is it gives you a broken arrow. This has your errors inside of your program. So in this case, it says my while loop conditional terminal is not wired. One of the downfalls of LabVIEW, I've programmed LabVIEW for many years, is their debugging is not that great, okay? In a procedural, text-based programming language, it'll tell you basically what line, your error is, correct? This is not as friendly, okay? It just gives you a big, okay, your error is somewhere in this black box, okay? You have to find it, okay? So the first thing you want to do is go ahead and go to your stop terminal, and notice how it turns into this kind of wire mode. Let me see if I can go ahead and move this up for everybody to see. So notice how my cursor changes to the wire mode, okay? This is similar to like Spice or Piecewise, whatever you want to call it. You can right click on the wiring, and you can say create constant, create control, or create indicator. Again, look at some of the tutorials. So we're going to create a constant. So we're going to say we're going to continue or stop if true. So we're going to feed it in a false condition. That way it keeps running forever. This is analogous to like a while one loop, okay, inside of a regular programming language. It's while one. It just runs forever, okay? This is actually your loop count or loop iteration count on the left-hand side. You might need to use that. So let's go ahead and make just a basic program. So let's look at the I/O palette. And we've got some familiar options. You've got move motors, stop motors. You can actually program individual motors. You can figure out what the encoders are reading. You can reset the encoders, things of that sort, okay? So let's just see if we can move the motors, okay? So this is going to be your basic block, okay? So it's going to take it just a second to load up that particular block. So now in LabVIEW, each one of these blocks you can think of as a function, like in C++, okay? A function has certain inputs and outputs, correct? You're going to feed in certain kind of arguments into that function, okay? Same exact thing with LabVIEW. Typically the convention with LabVIEW is all the connectors on the left-hand panel is usually your inputs. Everything on the right-hand panel is your outputs, okay? Sometimes there's things at the top and the bottom. It just kind of depends on what the particular sub-VI is for. So in this case, we have a couple options. We have the NXT EV3N. We have power and speed of motor 1 and the motors here. So at any time when you're first learning LabVIEW, I would suggest keeping this little context help menu up. This kind of shows you a little bit of a description of what every single one of these inputs and outputs are supposed to be, okay? You also can say detailed help here, and it'll let you know exactly what each one of those inputs are supposed to be. So in our case, we know we can add some motors to the top of this. That's what we're going to do. And again, I'm moving fairly quickly just because there's literally tons of, tutorials and stuff out there on this information. And plus, I'm going to post this video. All right, so I can right-click on any kind of terminal, and it'll give me an options menu that's specific to that terminal, okay? So notice how when I click on the NXT EV3, it gives me the I/O palette and the cluster palette, okay? But when I click on motors, it only gives me the I/O palette and the numerical palette. So it depends on what node you press on. Your context menu changes depending on what you press, okay? So in our case, let's go ahead and create a constant for our motors, okay? This is where naming your particular motors inside of your schematic editor is important, okay? So recall that we named the motors left motor, right motor inside of this schematic diagram editor, okay? See, left motor, right underscore motor, okay? That's actually going to show up here under our drop-down list. So there's my right motor, and then it'll go ahead and add the right motor. It takes a few seconds to load that particular subroutine. Then I can add another motor to it using the drop-down box. And of course, I'm just going to use the left motor in this case, okay? So again, if you use the smaller motors inside of your design, you can choose the little small motor from this as well. Okay, so there's my 2 motors. Notice how the icon dynamically changes depending on what you feed into it. Okay, before I only had the option for 1 power/speed input. Now I have the capability of doing it for 2 of them. Okay, so let's go ahead and right-click on one of these terminals and say create a constant. Okay, and if you recall in the other software, the EV3 software, 75 was just the default power speed, correct? Same exact thing. The reason why they're the same is this EV3 software is actually built on top of LabVIEW. So you don't know this, but you're actually running LabVIEW, see here, powered by LabVIEW, in the background. Okay, what it's done is it's actually has one more layer of abstraction to kind of take away some of the stuff we're doing here. It just makes it real simple for kids and stuff to look at. All right, so I can go ahead and say create another constant here and have 75 for both of my motors, okay? You also can choose a dynamic instance, okay? Does anybody remember what overloaded functions were in C++? You can have multiple instances of the same function. Same exact thing in LabVIEW. You can have the constant power instance of this particular function, or you can have the constant speed instance of this function. And the detailed help will explain all these different options that you have available to you. So the first thing it's asking for that you may not know is you have to actually initialize the the EV3 kit, whatever you're working with. Luckily for us, we already have the EV3 initialized at the bottom left because it says EV3 USB is connected. And let's do something else important here. Let's go ahead and make this into a case structure. So go under your structures, go under your case structure, and let's only move the motors forward if, I don't know, the touch sensor is pressed, right? How about something like that, okay? So let's go ahead and go to our I/O. We can go under our read sensor icon. It's going to take you a little while to get familiar with this. I think actually Dr. Conrad proposed that Thursday be a lab day for this particular, since we're just getting introduced to LabVIEW. All right, so again with the convention, the left sides are inputs, right sides are outputs. So notice how this says NXT EV3. Okay, we've seen this before. That's an input to the next one. Okay, so let's go ahead and tunnel that through into our EV3. Okay, this is analogous to passing variables inside of a function, right? Nothing new here. We're just passing variables from one function to another. You essentially do that in LabVIEW by connecting these 2 panes to each other. Okay, so let's go ahead and look at the output. Another thing I want to mention, again, if you've never looked at LabVIEW before, is the color convention inside of LabVIEW. Okay, the colors are significant. Okay, this pinkish color in LabVIEW is actually a string. The bluish color is an integer. Doubles are orange. Boolean is green. True, false. Okay. Again, I would suggest going and looking at some of these tutorials on this before I get started programming. Okay. So in this case, this particular case structure is looking for a true, false, some kind of Boolean input. Okay. Which actually, the case structure, again, which is analogous to the switch statement inside of the old program that we used, it actually dynamically changes depending on what you poured into it. So I can definitely port in this yes, no Boolean answer into the case structure, but I can also, let me show this here, I can choose the case structure, and let's just make let's go and copy this 75, okay? So let's copy this 75 block, Control-C, Control-V, tie that into the case structure, and now becomes a numerical case structure. Does that make sense? Everything dynamically changes based upon what input you give it, okay? A lot of this stuff is not really given to you. You just kind of have to figure this out over time. So Feel free to email me if you have some questions on how to port one code to the other, okay? But make sure you include screenshots of what you have so far, okay? Now, hopefully, has anybody got any questions so far? I know it's throwing a lot at you at one time, but again, there's a lot of tutorials out here on this. Yes? Yeah, still do Thursday. Still do Thursday. Now, it's due Thursday because what you were supposed to do is make like a 10-icon program in the EV3 software. How many of you actually did that? Simple program, it just goes, stops, end, something like that. Y'all guys should have no problem. If you didn't do that, what I would suggest doing is rethinking your algorithm from Lab 1. Even though I said, try to make it as close as you can. If it was me, I would rethink what I did for Lab 1 to make it as simple as possible, okay, to meet the minimum requirements. What are the minimum requirements? Anybody remember? 3 sensors that do something. Right? You can just touch the sensor, touch another sensor, and do something with the ultrasonic, and that's it, okay? So that's what I would suggest, okay? It may take you a few extra minutes just to kind of revamp your code inside of the EV3 software, but make something very simple, okay? The whole idea of this second lab is not to let you spend 50 hours on this, okay? The idea is to kind of get your feet wet with LabVIEW because hopefully you made a simple enough program in your other software to port it fairly easily into LabVIEW, okay? If you think your program's way too complicated, just scrap it. Make something real simple in the EV3 software. That way you have some kind of basis to go by when you port it into the LabVIEW. Does that make sense? You want something as simple as possible, okay? All right, so let's continue with our case here. So I'm saying that if the sensor is pressed, okay, that means it's true, okay? And that means that the motor should go at 75 speed. Okay, let me get rid of this other case structure here. And that's just one sensor. So let's see what this will look like on the actual. So I'm going to go ahead and deploy. This code should take just a few minutes to, let's see. Oh, I got to connect it here. Let me go ahead and disconnect it, connect it back.
You need a control for that sensor there? That code sensor?
It should automatically know what it's connected to because we entered that in the schematic editor, right? We told it which port it was supposed to be on, right? And the only other option it really gives us on this sensor is what ports it's on. So it should know port 1 because I gave it port 1 in the schematic editor. But if something's going on with your sensor, make sure that that port matches up with what's on the actual robot. Does that make sense? Okay. All right. Look, I've actually got to exit out of this program because it's actually taking up the EV3 instead of LabVIEW. So let me exit out of this. That's another important note too. You can't have both softwares open because the EV3 is going to recognize itself in one of the two softwares and it won't be available in the other. So now I should be able to disconnect, connect it again, and it should show up. Let's see what happens here. So let's choose our NXT. Everything's okay. All right, so let's go ahead. And again, there's two options. There's this run and there's deploy. We use deploy typically with our other software. So I'm taking a second to download. It does the exact same sound as the other software when it downloads. So again, I'm going to go into my robot, and it should, let me pull up the dash cam here, not dash cam, but the document camera, and it should show up as whatever you named it. Okay, in this particular case, it's LabVIEW V3. Does everybody see that? That's what I called it inside of LabVIEW, so everything should work the same. So I go ahead and press play on this guy. When I press the sensor in, it runs. Okay, it's just going to keep going because I don't have anything to stop it from running. Okay, top left button is the stop for that. Okay, all right. So any questions so far on what I did? Everybody good? Or sort of good? Yes.
Is there a way you can change variables or put variables in stuff?
Oh yeah. I mean, there's basically anything you can do with regular traditional programming you can do with this. Speaking of which, if you get really stuck inside of LabVIEW, but you know essentially what the C code should need to do to make the same action, what you can do is, let's see if they have. I don't think this particular form of LabVIEW gives you that option. Okay, but yeah, definitely the main palettes that we're looking at for this assignment is going to be the structures palette that gives you your while loop and your case structure, which is going to be your switch. Anybody do the Boolean operators in here, like the and, or the stuff like that? So that is located under the programming under the comparison, there's equal then. You can also do the Boolean here, which has and, or, all your different kind of Boolean operators are here. Again, if you find yourself spending a long time with this and you can't get your exact code ported over, just do something simple on the other side. See what I'm saying? I don't want you to spend forever on this. I just want you to kind of get familiar with LabVIEW. Okay? So let's go ahead and look at adding another sensor to this. Okay? The only other sensor that I have on my robot now is just the ultrasonic sensor. That's all I have. That's all I had time to build for. So let's say that if the sensor is pressed, it goes forward, but inside of that case structure, which again will automatically grow depending on how I move it around, let's go ahead and introduce another case structure for the other sensor. So let's go ahead and get the ultrasonic sensor. So we can choose, it defaults to the touch sensor. I can choose the EV3 ultrasonic. Again, if you're using the NXT kit, you're going to choose from these particular sensors here, okay? So let's choose the EV3 ultrasonic. And again, the same options are available to you. So you can choose centimeters, inches, or just listen for. So I'm going to choose inches. And I'm going to say, again, you have to tie in your EV3 into it because you're passing that same variable into that particular block. Again, in this case, it defaults to port 1. So I'm going to create a constant here. Now, which my ultrasonic sensor is actually on port number 4. Let me just double check that here. Yes, on port 4. So I want to choose from the drop-down menu to program port 4. Okay. If I left it at port 1, it wouldn't have worked. Okay. Typically, it ports it over for you. I don't know why it didn't, but typically it does. Okay, so in this particular case, the output is important to us. So the output for this particular sensor is going to be a single precision. Okay, remember what I said about orange? What data type is orange? Is double, right? That's what's coming out of that. Okay, so that's what's coming out of here. So I can say, let's go ahead and tie that into a, we can go ahead and convert. That actually would be a good idea to convert this. So let's go ahead and convert the single precision just to a, I don't know, a byte integer maybe. Let's see what happens here. Okay. The reason why I did that was because typically your case structure only accepts integers, booleans, and strings. That's basically the only inputs that it takes to it. Okay. So let's go ahead and look under a case structure here. And again, it starts off, it defaults to a boolean, accepting a boolean. But if I tie in a numerical to my case selector, which is what this little question mark is, it automatically updates to some kind of numerical update. Okay. So let's say if I press the sensor and the, actually I can do this right here as well. So what do you want to do? Let's let y'all be interactive for a second. So if I press the press the touch sensor, I get into this case structure, and then I want to do something with the ultrasonic sensor. What should I do? If I read a certain value, should the wheels move or something? Something like that. It makes some noise. All right. Okay, that's fine. I'll do that too. So let's do a quick comparison. Okay. So another thing too inside of LabVIEW, if you see the X here, that means there's an error. Okay. So in this particular case, I've disconnected a set of wires and it goes to nothing. Okay. It says wire has loose ends. You can go ahead and click on that and hit delete. That'll delete your wire. That'll also tell you if you have any errors in your program by looking at the run button. If the error is not broken, you're fine. If it's broken, that means you have some kind of error in your code. Okay. So let's do a quick comparison. Okay. So let's go under the comparison palette here and say, let's say if the ultrasonic sensor is less than, I don't know, how many inches do you want? Create a constant. So let's say if it's less than 7 inches, what do we want to do? I know, that's okay. It's okay. I got to put this on YouTube, okay? Let's keep it PG, okay? All right. All right, so let's go ahead and choose another case structure here. All right, so if it's less than 7, that output's going to give me a true or false value, okay? So that's going to go into here for my true false indicator, okay? Now, so if I press the sensor and the ultrasonic sensor is less than 7 inches, then should I move forward maybe? Let's try that, okay? Let's just go ahead and move this portion here inside of this case structure. I need to, of course, reconnect my loose ends into my program. Everything's good to go now. All right, so another thing we have to take into account typically is your false case. Okay, I won't do that for sake of time, but typically an error you might get is if you're doing something for a true case, it has to be in the false case. And so to the guy in the back's point, let's go and add a sound to this. So it's going to go forward, but while it's going forward, let's go ahead and make a sound. So here's the sound control. There's tone. You can play a sound file. I think it gives you the option to create a constant here. I can choose where that particular sound file is. Excuse me. Let me go ahead and choose let's just choose a tone for instance. Let's play the piano red song. I don't know what that is, but we'll go with it. Okay. So we're going to tie that into our NXT EV3 connector, and that's all you have to do is to tie it into it. Okay. All right. So what's this program supposed to do? Somebody walk me through it. What's it supposed to do? You guys got to read this, not me. I know what it did. I just did it. You got to know what it does. Press the touch sensor, then watch it happen. Okay. I mean, it doesn't really stop the motors, does it? Right? It just kind of keeps going. Okay. So we'll just roll with that. So let's go ahead and save our program and save often. We have to do that all the time. And let's go ahead and deploy. Okay. Takes a second. Should be deployed. So let's go ahead and see if I can get to that program again. Again, just to reiterate, it should be the same name that you gave it in the Lego EV3. Excuse me, the LabVIEW software. All right. So let's go ahead and press play. And there's the red, whatever the red sound was. I don't know what that was, but it should be okay. Okay, does that make sense? So, has anybody used anything in your other program that I've not went over? I've kind of alluded to where the comparison and/or stuff is. The sound, motors. Again, if you have the medium motor, I've got that's just another drop-down box. Yes. Color sensor. Again, that's just going to be under your sensors, your generic sensor, and you can automatically choose the EV3 color sensor from that option. And again, the block is going to change depending on what sensor you choose. Yes?
Can we run the motors based off rotation or angle?
Oh yeah, there's also that as well. So there's, under I/O, you can look at the motors. I believe it's under motors right here. So that kind of, you can, motor status, you can read the sensors, I believe, from there, or move servos. Okay. Should be somewhere in there, okay? If not, just a quick Google should be able to get that as well. Yes?
We had to do something like with a sequence, like a ladder sequence, I think it was called.
Okay.
Can you just talk about that for a second?
Sure, okay. So the only two structures that I've went through so far is just the while loop and the case structure, okay? Another structure that's going to be very similar to the EV3 software is what's called the flat sequence structure, okay? So let me give myself a little bit of room here. So a flat sequence structure is exactly as it sounds. It does stuff in a certain sequence, okay? It's supposed to be looking like old, I don't know, movie film, right? Like doing one frame at a time. It's a little bit outdated, but that's how it goes. So if you right-click on the right-hand side of the flat sequence, you can say Add Frame After. You can keep adding these frames. And essentially what LabVIEW will do is it'll perform whatever action you have in this sequence. And then you would tie, for example, this EV3 block into the next sequence. Then it'll go do the next particular sequence. So if you have a sequence in the EV3 software that says move forward for 2 seconds and then stop and then back up, whatever it may be, a flat sequence is probably the way to go. So talking about waiting, I will go over the time period for that. So if you look under the programming structure, I believe it's under time. So you can wait for a certain number of milliseconds. So if you want to go forward, but go forward for 2 seconds, you would have the same exact motor block here where you're going forward for a 75 speed. I'd paste that inside of here. Let me kind of move it out a little larger here. Move that up slightly. Again, I want to tie in my EV3 into here. And let's say I wanted to wait for 2 seconds, okay? So this is in milliseconds, so how many milliseconds are in a second? 1,000, right? So that would be for 2 seconds. What that would do would move the motors forward for 2 seconds. Then after that is complete, it would move to the next sequence to do whatever your heart desires. Okay, doesn't matter. Make a sound, make it go around, I don't know. Do your homework. If you figure that out, it's fine. It's no problem. Solve a Rubik's Cube. It should be good to go. Now again, just to reiterate, inside of your video, you're going to need to kind of show me some of the code. You can just show me with the camera, that's fine, explain. If it's rather large, just kind of make sure I can read. Stop and focus for at least a half a second so I can see. Don't just do a quick, oh, here's my code. I need at least a half a second for the camera to focus, okay? All right, and again, some of you in your side of your video for Lab 1 didn't include the code at all. Like you did, I don't know why. I guess kind of looked over a few of them. So again, you have until Wednesday night to redo that, okay? I would suggest just adding it in to the video. You can just, whatever editor you want, okay? I use Microsoft Movie Maker. It's pretty simple. It's free. Yes?
Can you declare a variable?
Yep. So declaring a variable, you go under Program Structures. You can say a local variable, right? So, and again, you can read more on this online. They have plenty of examples. Yes?
Whenever I tried to do the variable, it said something about using the front panel to name the variable.
Right. So yeah, so for instance, if we go back to the front panel here, again, I didn't want to throw too much at you at a time. There's a lot of videos on this specifically, using local variables and global variables. But let's just say you had a numerical, a numerical control, for instance. I could place that here, and the exact same control pops up on the block diagram. So I can call this, let's call this test just for a variable name. Now when I go and select a local variable, so let's go ahead and select a local variable, I can tie that into, my local variable. I got to choose a local variable. So there's tests, okay? And what that does essentially is it makes it to where you don't have to run a single wire all the way somewhere else. You can just kind of say an instance of it. So if I right click on this, I can say change to read, where it reads in that value, or I can say change to control, where I'm controlling. It's just a node. It's just like in piecewise. It's just controlling a certain node, sending something into it. Yes?
So if I want to say if condition that test one variable should be one, can I do it?
Well, you wouldn't use like an if statement. You would basically use the case selector, or case structure would be basically your if else statement, because true false is the same thing as if else in this particular case. And you can even choose that.
Can you update the variable?
Oh yeah, certainly. You would just change this to read, or to write, and whatever you tied into that local variable, it would update that variable. Everybody else okay? Everybody good? All right, so what are we going to do by tomorrow night? Wednesday night. By 11:59, you're going to update Lab 1 in case you messed up, right? Okay. Now, as far as I know, I've not confirmed this with Dr. Conrad, but I think Thursday is going to be a lab day to go over this. Again, please use Google first before you use me. I'm not using the word incorrectly. There are literally thousands of videos on LabVIEW out there, okay, on everything you've talked about, okay? There might be a few little quirks that's specific to the EV3 that it may not have a video for, but just the basic programming in LabVIEW, they got tons of videos, okay? So please look at that before you shoot me an email, okay? So I'm available after class if y'all guys want to start working on it. Again, Thursday is probably going to be a lab day. I'm going to post this video here in a few minutes. Hopefully the audio was okay, I hope. Any last questions? Everybody okay? All right, now what's something you have to do after you get done with Lab 2? Inventory on the box, okay? That's what those sheets of paper are for. Just do me a favor and go through and see what you're missing and mark that on the piece of paper, okay? And you can turn that in when you turn your kit in next week. All right? All right, guys, thanks a lot.